Hey everybody, video number 8. Back to the front board because I have to draw today. We're going to draw covalent compounds today, so let's get right into it. First, covalent compounds, two or more non-metals. They share electrons. You may want to try these in pencil the first few times. Okay, just saying. So first, we use a single dash to show a single bond. We need to understand this fundamentally. This dash does represent two shared electrons from each atom. Sometimes there are Regents questions about that. And it's usually about a double or a triple bond, which means there's more than one dash, which we'll learn. We'll get to those. Okay, and we'll do those in this video. And every atom must be represented and all the octets must be satisfied. Those are the basic rules. So my first example, I got HCl. I need to pair up the lonely electrons. So let's start. I'm gonna start these slow, and the practice has you go piecewise, and as you get more comfortable, you can get right into the real deal and draw it. Okay, so let's start slow. I got an H with a single dot, and I have a Cl, and we know Cl has 7. Okay, and then like it says there in bold, it says pair up only the lonely electrons. So the guys that are by themselves. So that's this right here. This guy and this guy are going to form a bond so that they got a neighbor and they can pair up. Okay, so once I do that, I need to redraw this with a dash for every bond or every big circle loop. So that's going to look something a little bit more like this. H dash Cl. Now that dash is this, me connecting those lines, okay? So then I have to bring in all those other valence electrons that were there. And this is the correct Lewis dot for HCl. Okay, and then that dash represents the bond, which is one electron from hydrogen and one electron from chlorine. That's hidden in that dash. So that's the new learning. That's the piece that is not necessarily visible or doesn't necessarily make sense, but that's what's going on. That dash means there's a bond, 2 electrons, 1 from each. How shall we do a bunch until we get the hang of it? Okay, good. So practice wants you to do them out piecewise. So that's H with 1 valence electron. I'm going to color code just to make life easier for us. H and 1 valence electron. I'm going to go ahead and pair up the lone electrons, which is this, and so that is my bond. So it's literally just going to be H dash H. Remember, H's are the ones that don't need the octet; they need the duet. They can only have 2, so they are full. And I don't want you to draw this piece. I probably should have done this on the last slide. If you draw an imaginary circle around there, that bond is 2 electrons. So H has his duet. And if I do the same on the other H, that H has his 2, and that's what we call the sharing. So that overlap is where the bond is, and that overlap is where the 2 electrons are that are being shared. Okay, that overlap is key. That is where the sharing is happening. That's where the bond is made. So that's what H diatomic hydrogen looks like. Let's get right into H2O. My pieces, I have 1 H, and I'm going to draw the other H on the other side just because I have some instincts about this. And then I'm going to do my O, first 2 together, 1 at a time around the bus. This is legit. I didn't really matter for chlorine. And then I'm going to go ahead and circle these bad boys up. So these 2 are going to form a bond there. And these 2 are going to form a bond there. So let me redraw my O. And I'll put my valence electrons right where I see them. I have a bond on the bottom, and I have a bond on the side. Okay, so that is water, H2O, and it does have that weird shape. A lot of times I draw it slightly turned so that the O's here and then the H's are here. But it's the same thing, it's just slightly, let's see if the snowboard will do. Didn't let me do that. Okay, so back, sorry. There we go. So NH3, here I have 3 H's, so H, H. I'm going to do my N. Nitrogen has 5 valence electrons. I'm starting to color code this. So let's see, these 2 bond, these 2 bond, these 2 bond. Pairing up my electrons. So that gives me nitrogen in the middle with these 2 electrons up top. I have 1 hydrogen to the left. I have 1 hydrogen on the bottom. I have 1 hydrogen. Good. That's ammonia. NH3. We'll learn the covalent way of naming that, but that comes in a minute. So there's the first set. Let's move on to single bonds, and then we'll get on to triple bonds. There's a whole set of rules you could follow if you wanted to do the rules. This seems to be an easier method for students when they're first learning the first time. There is a whole set of rules where we don't have to do these whole circle of the lone electrons. So if this one isn't working for you, I can give you guys a set of rules if you'd like, but I don't want to give everybody a set of the rules because the rules seem cumbersome. So 6 valence electrons for this oxygen. And then I got 6 valence electrons for this oxygen. And again, we just pair up lone electrons, right? So these 2 bond, and then these 2 bond. And by the way, it doesn't really matter which ones bond as long as you're bonding lone electrons. That's all that matters. Doesn't matter that I bonded the bottom 2. Okay. But I see here's the key. I have 2 bonds now between these oxygens. So this looks like this. Circle, double bond, and then I have to bring over my valence electrons from the O. Each one had valence dots. So there we go. CO2. Remember, carbon does this. 1, 2, 3, 4. So we got to remember carbon does that from our previous learning. And then I have an oxygen with 1, 2. I'm going to go the other way this time with this, just because that puts my lone electrons in the middle, makes it a little easier. And then the other oxygen, I'm going to go the other way with it. So my lone electrons are facing my inner atom, which makes it easier to circle them up. So now I can go here and here, and I can go here and here. So now when I redraw that, I have carbon in the middle with 1, 2 bonds to this oxygen, 1, 2 bonds to this oxygen. Bring down my dots. And again, if I were to double check myself, and I don't want you to draw this on your paper, I want you to listen and understand, right? If I were to put a circle around here, there's 8 electrons. I got 4 dots, and I have 4 electrons hidden in 2 bonds. 4 and 4 is 8. Again, same thing here. I have 8 electrons around that oxygen, so I'm satisfied. And if you do go around the carbon, 4 bonds, 2 electrons each, 8 electrons around my carbon. So my octets are satisfied, and that is a mental check that you can do to make sure that you've drawn these things right. Some of them, like carbon dioxide, is one that is very commonly needed to be drawn. Let me put it that way. All right, silicon dioxide, Si, I think, let me check my periodic table. I think Si is also going to be like carbon. I told you carbon's the only one. Well, guess what? In this case, silicon's going to do it also because it has to. You'll figure out that if you do it the other way, it won't make enough bonds. So you have to just separate it out. So carbon, silicon. Break the rules. There we go. Bottom up. Bottom up. That gives me Si in the middle. 1, 2 bonds to an oxygen. 1, 2 bonds to an oxygen. Don't forget my lone electrons. And we're good. Now, we've done single bonds. We've done double bonds. Time for one last one, the big bad triple bond. Okay? Nitrogen. Drawing nitrogen. 1, 2, 3, 4, 5. And then over here, another nitrogen. Drawing my pieces. 1, 2, 3, 4, 5. I'm going to bond these bad boys up. This bonds. This bonds. This one bonds. All 3 of these form a bond. Just notice I have 3 hashes now. So this nitrogen is notorious for making a 1, 2, 3 triple bond. And I'm going to put my electrons on the end. I'm only going to put my electrons on the end because of my previous learning and my previous, how I was taught to do things. 2 negatives would repel. If you keep your two electrons up top the way we drew it in the pieces, and you keep them up top and you put them up top, I'm not going to mark you wrong on something like that. You need the right number of electrons. You need the right number of bonds. Everybody has to have their octets filled. And other than that, then I really don't care where those two electrons go. They really should be together. If they're on the top, the side, or the bottom, I'm not really going to raise a lot of stink about that. I would, just for properness, put them as far apart as possible because they're negative, and that's what they would do. So we need to know that single bonds have one dash, which is two electrons, which also equals one pair of electrons. Think about a pair of sneakers. How many sneakers is that? So don't get confused if you see the word pair. The Regents exam likes to be very sneaky sometimes and say, how many shared electrons in diatomic nitrogen? You have to say 6. Or it could say, how many pairs of electrons are shared in diatomic nitrogen? And then the answer is 3, because there's 3 pairs. Okay, the pair is a bond. So I want to make sure that we hit that because that's a little nuance in the wording that happens sometimes. Sorry about your luck. Double bond is going to be 2 dashes, 2 electrons each, 2 pairs of electrons, hence 4 total electrons. Okay. Triple bonds are going to have 3 dashes. They're going to have 2 electrons each, therefore 3 pairs of electrons, therefore 6 valence electrons. For those of us in bonus class, 6 valence electrons. Ready? And I think we are out. It's over. Over. See you guys in school tomorrow. Happy learning.